Before we start, I just wanted to point out that when I was speaking about the DBA versus developer, everything I said was the opposite of what was true. Because I had a question over the break where someone had misunderstood and thought I was telling you the best practice. I was giving you the worst practice, the opposite of the way to be. So don't do this picture. DBAs and developers work together. Be friends, not on opposite sides of a fence. But what I'm going to talk about next are a couple of new things about 11G Release 2. These are new things that you may not have heard about. Larry Ellison would not get up on a stage and talk about the first thing I'm going to talk about, a feature I call do-it-yourself parallelism. He would talk about real application clusters, automatic storage management, the grid, scalability enhancements, many features that you've probably heard about either in the press or through other seminars or reading through the documentation. My goal with this presentation was to point out some of the other features that don't get the publicity, the press, that the other big, large features get. So going through the documentation, I found a couple of things that I looked at and said, yes, I will be able to use these immediately. This is something I've been asking for, wanting in the database for a while. So without any further introduction, we'll get into these. The first one is do-it-yourself parallelism. This is the ability to take a single SQL statement and have it be broken up into small pieces. Each piece will be executed independent of every other piece. So it's the ability to take an update statement. It's going to update 1 million records and break it up into 10 update statements, each that will update 100,000 of those records. So instead of updating everything in a single statement, I'm going to break it up into smaller statements. Now that sounds like I've just conflicted with what I said previously. Write less code, do more in a single SQL statement. That is true in general. But in a large batch operation, sometimes you have to update millions, tens of millions, hundreds of millions of records in a single operation. And you would like to break that up so that if the statement fails partway through, I ran out of space, I ran out of CPU, and my session was killed, I ran out of memory, I'd like the work that I had performed to be committed and saved, and so I can just restart the statement and pick up where I left off. That's what this feature allows us to do, to take a single SQL statement and break it into many smaller SQL statements. Each one can do their work and commit, make their changes permanent without affecting the other SQL statements that are running. This is something I have been doing for years. I used to do it very manually. If you search for DIY, which stands for Do It Yourself, parallel on AskTom, you'll see how I've done this. I wrote a query that goes to the data dictionary, figures out how the storage is allocated for the table, and then we break the table up into some number of pieces. I would create a row ID range for each of those pieces. It tells me where the low part of the data is and the high part of the data. I would then remember all those values, and I would use those in SQL statements to update each chunk, each piece of the table. It was a very labor-intensive process. It took a lot of work. I wrote a chapter on how to do it. It took quite a few pages. It was a technique a lot of people used. In 11G Release 2, it's much easier. I don't have to write a lot of my own code. I can use a simple built-in package to do it. In fact, I'm working on a rewrite of my last book, And it will be really nice when I get to the parallel chapter, because I'm going to get to remove a lot of code. There will be less bugs in my next book, because there will be less code in my book, because they've automated something we used to do manually. And so this package that I'm going to demonstrate is called a dbms parallel execute. And we'll take a look at how it works. And I think that would be the easiest way to understand what it actually does. So in order to demonstrate this, I'm going to create a table. And I'm going to create it as a copy of the all objects data dictionary view. That's what my stage table is. So I just created a copy of that, gather statistics, and if I look at this table, I can see right now it has about 1,000 database blocks. My goal is to update every row in this large table. And when I'm doing the update, I don't want to touch more than 10% of the table at any point in time. That's the most amount of work I'm willing to lose if somebody turned off the power to my machine while the update is happening. That's the most amount of data that I want to lock at any point in time. If I did an update of every row in the table, I would lock the entire table. Using this approach, I will only lock 10% of the table at a time. So we'll remember that number, 100 blocks. Now I'm going to start using the dbms parallel execute package. And what I'm going to do is I'm going to take my table that I just created, user.t, and I'm going to break it up into pieces that are approximately 100 blocks apiece. So this has automated that query that I was talking about, the query that would go against the data dictionary and generate all those row ID ranges. Because what this just did was generate those row ID ranges for me. And it populated them into a new DBA view. There's a user view for this as well. But in a view, parallel execute chunks, there will be some number of rows with start row ID and end row ID. This covers a portion of the table. And if I took each one of those row ID ranges and unioned them all together, that would cover the entire database table. So this is started to set up the ability to update all of this table in small pieces rather than in one single call. Once I've created these chunks, I'm going to run my update statement. So here's the update statement. I wanted to update every single row and lowercase the object name column. Now I didn't want to do it as a single SQL statement, but I still want to do it easily. So all I have to do here is parameterize it, add the bind variables, so that the update statement knows only get this portion of the table. So anything that I add these two bind variables to can be passed in as the SQL statement and executed in parallel. Now, I broke the table up into at least 10 pieces because I told it to do 100 blocks at a time, and there's 1,000 blocks in the table. When I executed this statement, I used parallel 2. So it took 2 of those row ID ranges and started running them. When one of those updates was finished, it picked another one and started that. So even though I broke it into 10 pieces, I only ran 2 of them at a time. This allows me to do a little bit of parallel processing, which is good. It might be better performance. But it also means that I can break the table up into hundreds of small pieces, but not have to do all 100 of them simultaneously. I don't have to overwhelm the machine. I don't have to utilize more CPU than I actually have. So this went through and updated all those rows. And if I look at that view again, the status has changed from unassigned to processed. So the database is logging this all for me. If we were to have queried this while the previous stored procedure was running, in the running of the task, we would have been able to see the rows that were not yet processed, unassigned, the ones that had